Hello, dear students. Today we will learn about solving simultaneous equations graphically, which means I want to find the point of intersection of the two lines. If you graph two lines, they will intersect at a point, for example, you will find this point. But we have actually three options. The first option, I have the two lines are intersecting in one point like this. So from the graph, you will graph the two lines and then get the point that they will meet in. The second option, if the two lines are parallel, from the graph as well, if you find that the two lines are parallel, it means they will not intersect, so there is no solution. For the third case, I have the two lines are coincident, which means the two lines are on top of each other, so they will meet in every point. You have infinite number of points on the lines common between the two lines. Every point on the first line will be as well on the second line. These are the three options that you have. Next, I will solve an example. This example, he is asking you to solve these simultaneous equations using these two tables, which is called table of values. It means I have, for example, the first equation, y equals x plus 1. I will substitute the x values by the x values in the table to find the y values. For the first one, simply x is 0, so y will be equals to 1. For the second x value, if x equals to y equals to 3. For the third x value, x equals 4, so y will be equals to 5. Then let's continue the second table as well, but with different equation. I will substitute in a different equation. Still, I have the x values here, and I will substitute by these values in the equation to get the y values. If you substitute by 0, 2 multiplied by 0 is 0, minus 2, that will be negative 2. The second x value, if you substitute x by 2, 2 multiplied by 2 equals 4, minus 2 is 2. Third x value is 4. 4 multiplied by 2, 8. 8 minus 2 is 6. Let's graph the two lines. The first line, first point is 0 and 1. 0 and 1, 0 x value. 1 is the y value. The second point, 2 and 3, x and y, x2, y3. The third point will be 4 and 5 here. When you graph the line, if you didn't get a straight line, it means you have something wrong in your calculation. So you revise your calculations. Then I will extend it from the other side. That is my first line. Let's graph the second line as well, which is y equals to x minus 2. The first point, 0 and negative 2, that is your first point. Then 2 and 2, that's the second point. 4 and 6, that is your third point. As well, if I graph it and it didn't form a straight line, it means I have something wrong. Okay, with this, let's extend it from the other side as well. Okay. From that graph, if I want to get the point of intersection, it's nearly this point, which is 3 and 4. So 3, 4 is the point of intersection of these two lines. Okay, that's the first the first way to use the table of values if it's given in the problem. I have another way as well. If you are not given, this is the same question as well, but I didn't add the table of values. So let's check how will we solve it. Without the table of values, there is another way using the y-intercept and the rise over the run. First, the first equation here is y equals x plus 1, okay? Y equals x plus 1, it means that the y-intercept is the 1. So the first thing, I plot the y-intercept, the point 1 on the y-axis. That's my first point for the first line. Then I will use the gradient, which is 1 from the equation. Remember, y equals mx plus c. The m is 1. So if the gradient is a whole number, I will write it as a fraction. You know that any whole number can be represented as a fraction if you write it over 1. I need to have a gradient as a fraction because when I use the rise over the run, I need to make a vertical move and a horizontal move. According to this fraction, the gradient is 1 over 1. So according to this, I will move the numerator, I will move vertical moves. For positive values, I will move up. For negative values, I will move down. So here it is a positive value, so I will move 1 step up. For the denominator, you will move right or left. If it's positive, I will move right. If it's negative, I will move left. But here it's positive as well, so I will move 1 step right. So from the 1 on the y-axis, I will move 1 step up, 1 step right. Then you will get the point 1 and 2. That's if I move like this. Let me show you. I move like this, 1 step here up, then 1 step right. That will lead you to the point 1 and 2. Then I graph the line like this, connect the 2 points, then I have the first line. The same way for the second equation, y equals 2x minus 2, I will get the y-intercept, which is negative 2. So the first point that you plot on the y-axis is negative 2. And then I will get my gradient as well. The gradient is 2, but I have to write it as a fraction to use the rise over the run strategy. The 2 in the numerator is positive, so it means I will move 2 steps up. And then the denominator, I have 1. I will move 1 step to the right. From the negative 2, if you move 2 steps up and 1 step right, you will reach the point 1 on the x-axis. Then connect it as well. Connect these 2 points. You will get the line and the point of intersection. Like the previous example, exactly, it is the point here, which is 3 and 4. So I solved this using 2 ways, graphically as well, but one using the table of values and the other one using the rise over the run and the y-intercept. I hope you understand this well. Thank you.